Oh, I think this might be the last video. Well, maybe we'll do like a goodbye video or something, but this might be the last like chemistry video, which is a good thing. Yeah. Okay. So, spring study guide. Here we are. There's a lot of stuff in here. But I think that the foundation that you guys built this year has prepared you to excel in this particular set of questions. So, here we go. What is the charge on calcium? In order to figure that out, you just need to look at your old periodic table here and find calcium and look up here at the oxidation number for these alkaline earth metals, and you'll see that it's +2. So there's a 99.99999% chance if you find a calcium atom in the world, it's going to have a +2 charge. Yeah. The next question says, what's the formula for calcium chloride? Well, in order to do that, we need to consider the charge on calcium and the charge on chloride. So the charge on calcium is 2 plus, and the charge on chloride is 1 minus. I know I'm not zooming in here, but you guys all have this, so you know this. So anyway, if we've got calcium with its 2 plus charge, and then we've got chloride with its 1 minus charge, we end up like that. And then we can write them again down here like that. And we can take this invisible 1 and we can put it right here, but it's still invisible. And we can take this 2 and we can put it right here. So the charge, or the formula for calcium chloride, would be CaCl2. You need 1 calcium and 2 chlorides. The reason you need 2 chlorides is because they only have a charge magnitude of 1, whereas the calcium has a charge magnitude of 2. Okay, the next question says, what's the name for this thing right here? I'm not even going to read that out because when I see that, I just say the name, which is what you guys do too. It's calcium nitrate. We got our cation, which is calcium, and we got our anion, which is nitrate. We don't have any transition metals, so we don't need any Roman numerals or anything. So the formula for that sucker is calcium nitrate, or the name of it. How many grams does 1 mole of calcium nitrate weigh? Let's check it out. So we got calcium nitrate, it's the name of that sucker. So it would help if we could visualize what calcium nitrate looks like. And calcium nitrate looks like this. Our cation is a calcium ion with a 2 plus charge, and we have 2 anions, 2 nitrate ions. And nitrates are polyatomic ions. So I drew their Lewis structure in here and showing their charge, -1. But the handy thing here is that we can see that we've got 1 calcium atom and 2 nitrogen atoms, and we've got 1, 2, 3, 4, 5, 6 oxygen atoms. So 1 calcium weighs this much per mole, 1 nitrogen weighs this much per mole, 1 oxygen, or 2 nitrogens weighs this much per mole. 6 oxygens weighs this much per mole. And the way I got that is I just took 16, which is how much 1 mole of oxygen weighs, and multiplied it by 6 to get 96. We add all that up and we get the molar mass of calcium nitrate, which is 164.1 grams. Yeah. Okay. How many grams does 0.37 moles of calcium nitrate weighs? Well, you probably just figure out that you just need to multiply that molar mass by 0.37, but we want to justify it and we want to use these tools that we learned so far this year. So here's how we did it. Oh no, I did 3.7 moles. Was it supposed to be 0.37? Rats. Okay, well, I can just move the decimal place over 1. So this is actually supposed to be 0.37 moles right here. Sorry, let me bring that up for you guys. So this is supposed to be 0.37 moles. And if 0.37 moles, if we multiply that by the molar mass, which is 164.1 grams per 1 mole, then what we would get is 60.72 grams. Yeah, it's going to weigh less than 1 mole. So that makes sense. Good. Okay. Next, how many moles of calcium nitrate is 400 grams of calcium nitrate? Okay, so let's start with 400 grams of calcium nitrate, which is our measurement here. And we're going to multiply that by 1 mole per this many grams. See how we had this fraction flipped up here? You can flip these things around, remember, any way you want in order to get rid of the units that you don't want. In number 5, we didn't want moles. We wanted to end up with grams. So that's what we ended up with. And in number 6, we want to get rid of grams and end up with moles, which is what we did. So anyway, there's 2.44 moles of calcium nitrate in 400 grams of calcium nitrate. Yeah? Okay. Next, what is the molar concentration of a 2.5 liter solution that contains 100 grams of calcium nitrate? Seems pretty overwhelming, doesn't it? Well, it's not so bad as long as you remember something. You need to remember what molar concentration means. And molar concentration means moles per liter, or moles divided by liters. Once you remember that, then everything's cool. So we start with 100 grams of calcium nitrate. You could start with 2.5 liters. That's all right. You just need to know that it needs to go on the bottom. So you could do that. It's fine. But I started with 100 grams of calcium nitrate. Watch. So I started with 100 grams of calcium nitrate, and I multiplied that by the molar mass of calcium nitrate, and then grams of calcium nitrate. Grams of calcium nitrate is gone, and we're left with moles of calcium nitrate. And over here, we want moles divided by liters. So liters needs to go on the bottom down here. So I just put it on the bottom. I had to put something on top, so I put 1 up there. And now we have moles divided by liters, which is what molarity is. So if I do 100 divided by 164.1 divided by 2.5, I get about a 1/4 molar concentration of calcium nitrate. Yeah, sweet. Okay, and by the way, like text me or email me or whatever if you got any questions with any of these beauties, okay? How many grams? Yeah. How many grams of calcium nitrate would you need to make a 1/4 liter of 0.35 molar calcium nitrate? Alrighty then. So there's a couple things we need to make sure we understand here. We need to make sure that we understand that 250 milliliters is a 1/4 liter. You need to move the decimal 3 places, 1, 2, 3 to right there. So it's 0.25 liters. The other thing we need to realize is that 0.35 molar means 0.35 moles of your solute per 1 liter of solution. You have to know that also. If you don't know those things, then you're not going anywhere. But now you know them, so you're sweet. Okay, so we want to figure out how many grams are in there. So we know that we're going to need grams on top. So I'm going to start with the 0.35 molar, which means 0.35 moles per liter. And then I need to get rid of moles. So I'm going to put moles on the bottom and grams on top because grams is what we want. And then moles of calcium nitrate is crossed out. And then we have 164.1 grams per liter. But we don't have a whole liter. We only have a 1/4 liter. So I need to put that up there, and then liters is going to be gone. So I need to multiply by 0.25. So this times this times this, it means there's 14.3 grams of calcium nitrate up in that solution, which is good to know if your boss tells you to go make them a quarter liter of 0.35 molar calcium nitrate. You better know that. All right. So now we're getting to acid-base stuff. So which has more electrons, water or hydronium? Hint, recall how water becomes hydronium. Here's how water becomes hydronium, like this. Water becomes hydronium when one water molecule or some other acid donates a proton to another water molecule. And then this water molecule is going to become hydronium. And if our acid here was water, then it's going to become hydroxide. Over here, this could be like hydrochloric acid or something instead. We need something to donate a proton to water in order to turn water into hydronium. So anyway, what this hydronium over here has that this water molecule doesn't is one single particle. And that particle is a hydrogen ion, also known as a proton. So this water molecule gained a proton. Did it gain any electrons? No. Did it lose any electrons? No. So it has the same number of electrons than it started with. Therefore, hydronium and water have the same number of electrons. Thank you very much. What do acids do? Even bad. Bases accept protons. Acids donate protons. Acids donate protons. That's what they do. What's the name of HCl? It's hydrochloric acid. What's the formula for hydrofluoric acid? It's HF. What's the name for this sucker right here? It's nitric acid. Want to know why? Fine, I'll show you. Here's why. So nitrate is the anion. So we're going to, if it ends in 8, then you change it to ic. So it's going to be nitric acid. Yeah? And the next one says, what is the formula for sulfuric acid? So again, eit us 8 ic. Eit us 8 ic. So 8 turns to ic. So sulfuric acid must be made out of a sulfate ion. So all we have to do is take a sulfate ion, which has a charge of 2 minus. How do I know that? Because it's right here. Sulfate has a charge of 2 minus, and I need to make a salt out of it. But I can't just use any old cation to make the salt. I need to use hydrogen ions. So how many hydrogen ions? 2, because sulfate has a 2 minus charge. So we need 2 protons, 2 hydrogen ions to make this salt, this acid salt. So the formula is going to be H2SO4. That's opposed to sulfurous acid, which comes from the sulfite ion. And the sulfite ion is right here. Sulfite, sulfate, sulfite, sulfate, sulfite, sulfate. So sulfite also has a 2 minus charge. The only difference is it's got 3 oxygens instead of 4. So the formula is going to be H2SO3. That's nice. Okay, write the equation for the dissociation of nitric acid. What's dissociation? Dissociation is a breakup. Association, dissociation. So we need to show the breakup of nitric acid. So how are we going to do that? Here's how we're going to do it. We got nitric acid right here. We're going to show it breaking up into ions. It's going to break into 1 proton and 2 nitrates. if we did it with sulfuric acid, it would break into 2 protons and 1 sulfate ion. Yeah? So that's a dissociation equation for an acid, just like all the other salts. You just break it into cations and anions. Okay, what does this gibberish mean? Well, the square brackets mean concentration, and this chemical in here, this reads carbonic acid, better act somebody. So what this means is, this means the concentration of carbonic acid. That's what it means. When somebody writes that, you read concentration of carbonic acid. That's what that means. Yeah. Teaching you guys heck of chemistry up in here. Okay. In a 3.4 molar solution of nitric acid, what is the concentration of hydronium? Well, nitric acid is a strong acid, and strong acids donate every single one of their protons to water molecules, if there's water molecules around for them to do that with. And in a 3.4 molar solution, we're going to have a whole bunch of water molecules in there. So the concentration of hydronium in 3.4 molar nitric acid is 3.4 molar hydronium. If the concentration of nitric acid is 3.4 molar, then the concentration of hydronium is also 3.4 molar. Yes, that's the definition of strong acids. That's what they do. They fully react with water to form hydronium, every single one of them. Okay, where are we at? If you measured the pH of a solution of hydrochloric acid and found it to be 45/100ths, what is the concentration of hydronium in the solution? Well, you need to know, how to translate from a pH to a concentration of hydronium. And in order to do that, you use a handy formula that looks like this. Did I skip something? No, I'm right here. So 10 to the opposite of the pH power is equal to the hydronium ion concentration. So the hydronium concentration in this case equals 10 to the negative 0.45, which is 0.35 molar. I'm not going to show you guys how to do that in this calculator again. You're going to have to look back to that video if you don't remember how to do that in your calculator there, because you're going to have to know how to do it for the final. So if you don't know how to do that, go ahead and review that. Make sure you got that Desmos app on your phone. Okay, what are we on now? If you measured the pH of a solution of hydrochloric acid and found it to be 0.45, what is the concentration of hydrochloric acid in the solution? In other words, what would you write on the concentration? What would you write on the bottle's label for the concentration of hydrochloric acid? So hydrochloric acid is a strong acid. So if you have 0.35 molar hydronium, then you have 0.35 molar hydrochloric acid. Yeah, that's just the deal. The deal with strong acids and strong bases is that the concentration of the strong acid is equal to the concentration of hydronium in that solution. Okay, finally. Is this finally? Yeah, this is finally. If you measured, this is the money question right here. This is it, man. This is it. If you can do this question standalone all by itself without all this background stuff, then you deserve an A in applied chemistry class. If you measured the pH of a solution of hydrochloric acid and found it to be 45/100ths, how many grams of hydrochloric acid did the chemist use to make the solution? The volume of the solution is 1 liter. Wow, that sure sounds overwhelming to me. So let's break it down here. If you have a 0.35 molar solution of hydrochloric acid, then you have 0.35 moles of hydrochloric acid for every 1 liter of solution. Incidentally, we do have 1 liter of solution here. And if you use your periodic table to figure out what the molar mass of hydrochloric acid is by adding up the molar masses of hydrogen and chloride, then you'll find that the molar mass is 36.46 grams per 1 mole. And then you can see that moles of hydrochloric acid cancels out, moles of hydrochloric acid cancels out. That means that there's 36.46 grams of hydrogen chloride for every liter of solution. And they told us that we have a liter of solution, so we're done with 12.76 grams of hydrochloric acid. So that's it for that study guide. I'm going to give you guys this final. I don't know. I'll tell you on Classroom when, because today's the day before this day. So I don't know yet, but I'll totally know. Miss you guys. Hope you do great on this final. Okay, bye.